Tell me when.
Go now.
All right. Hi. Welcome to the second video of Electronic Navy Electronic Training Series charts for Sinusoidal Wave, No More Nonlinear Equation, Kevin Spacey movies, okay, on the MIT Blackjack. So what I want to teach you is this sliding ruler, right? Can do any type of math real quick with your resistor, indicator, induction coils, RLC circuits, and fuses. Okay, so let's take a look about about bandwidth, envelopes, binary equations, and different sinusoidal waves. Okay, so let's move into the square right here. You have 360 degrees. You have a negative in the amp. You have 360 degree quadrant one. This is your linear equation. Here it runs in a linear equation, combined linear with nonlinear, showing the different frequencies. Here is when you have a wavelength going in these are the wavelengths. These are up and down. So they are, when you smush them, waveband is larger. You can set it in, you can set it out. You can space it out, and you get different, see we have the vertical deflection voltage, and the time, the distance, and the rate. The horizontal deflection voltage, with these come in different envelopes. This is a sin. You have the sin and your cosines. The circle one's very important. If you have a receiver, you can move it forward by dividing 4 pi, the quadrants to 4 pi by its amps, and it will move in and hone in onto where the next modulator is. So over here, we have our frequency spectrums usage. We have the communication navigational, VLF. We have the different VHF. These are frequency spectrums. We have modulator modules all the envelopes together. So over here it shows an envelope. I believe that's a resultant envelope. And when you put them together, it comes in envelopes. There's many different signals in one, and they rate on different peaks, which are rated by different capacitors. So that's that. We have your modulation circuit in 360 degrees, an upper band, a carrier band, a lower band, a peak voltage envelope, and the modulation envelope, which picks up these peaks at different sim waves, just like you see on your wave when you watch your videos. So we have a carrier side band, an upper side band, lower upper carrier. Okay, 3D vertical band time. This one is induction and resistor time constant, growth and decay, that deals with battery voltage. So we have our spectrum distrum, and if you can think about the volts going in this way, and the modulation square is binary. So we have these different waves, and you can see as they pick up on different, so you have different capacitors or resistors going this way, like horizontally, you can pick up different wave band lengths. And here's the truth about decay and resistance. And I'm doing this really quick so my sister does. We have a decibel, gain, and power. Those come with these voltages. You got to follow these, at least these basic Boolean laws, your basic algebra, identity law of identity, commutative, associative, indeponent, double negative commutative, law of intersection union, De Morgan theorem, distributed law of distortion, common identities. And that's a quick overview of this board. Okay, right down here on this bottom one, it shows you the frequencies for your designated bandwidths. And I believe that's quick overview. You can cut the video, Paula.